Hello everybody, welcome to episode number 11 of the BIVBlog, Benedict's IT video blog. My name is still Benedict Stockebrand, and as I promised in the previous episode, this time I want to give you a bit more background on the business case of IPv6. So this time we have to talk a bit about technology. I'm not going to get into much detail, so if you expect another black t-shirt episode, wait for the next one. But I'll try to keep things reasonably simple so it's understandable to people not too closely involved with the technological aspects here. Now, as I mentioned, the internet is currently moving towards IPv6. The ISPs have no other option but to move to IPv6 and take their customers with them. What's going on there in detail? Now, the internet is based on a technology called IP, Internet Protocol. And one of the features of IP is that it provides all devices connected to the internet with an IP address, which is basically like a phone number. Problem is that around about 40 years ago, when people came up with the idea of some sort of internet technology, they thought that about 4.3 billion addresses should be perfectly reasonably big enough. At that time it was, but things have changed. By now we've got about 8 billion people on the earth, and some of them have more than one device to connect to the internet, so we actually have a problem. And the situation got seriously unpleasant about almost 20 years ago, and at that point we've introduced technologies that make it possible to kind of share these IP addresses. First thing that we've done was to assign addresses dynamically. So basically, if you turn your device off, you release the IP address it has, and next time you turn it on, it probably gets a different one. That used to work reasonably well, had a lot of problems with it already, but we've been so used to it for so long that we hardly ever notice. If you want to try to provide some sort of web server, for example, from your home, and you find out that this is a problem there. Second technology we used after that was network address translation, NAT, which basically hides multiple devices behind a single address. And that's what pretty much all your home routers these days do. And they've been doing so for at least another 15 years. And that makes it even more fun if you try to make a device accessible from outside while it's still at home. And we sort of got along with this somehow. It has a number of problems, number of drawbacks, made things less reliable, more troublesome, but well, that's the internet. And who would expect the internet to be as reliable as traditional telephony service anyway? So that's the situation we've had until a few years ago, but it was already obvious that these measures wouldn't last forever. The internet is still growing, and even with these by now well-known and well-hated tricks, we don't get any further. It's simply no longer enough. And for the ISPs, that's a huge problem. They've been using all these workarounds to connect an ever-increasing number of people to the internet, but a year and a half ago, the organizations that managed IP addresses at the very top of the hierarchy have run out of addresses. First, the IANA, the Internet Assigned Numbers Authority, who delegates addresses to the regional IP address trees, the RARs, and out of the 5 RARs, the one responsible for Asian Pacific space, APNIC, Asian Pacific Network Information Center, ran out within weeks after IANA was running out of addresses. And shortly after, the European Middle East RIPE, Réseau IP Européen, French name, located in Amsterdam in the Netherlands, and well, they ran out of addresses as well. So by now we have a situation that in some parts of the world you simply don't get any new addresses if you're an ISP. The reason that these addresses aren't being sold but are given out on an as needed basis were quite sensible at the time this system was established, but by now of course it means if you can't trade things freely and there is demand for it, we do have an increasing black market. So buying addresses is kind of an option for the growing ISPs, but it's expensive and you're not really supposed to do that, so the ISPs try to avoid that. On the other hand, they have an increasing need for addresses. Even the ISPs that don't grow because they're using some boring telephone line based technology like DSL, they have the problem that a few years ago a surprising lot of people would actually have a PC or whatever at home, have a DSL modem or router connected to it, and they put it on a switchable power strip, and as soon as they switched off the computer they switched off their router as well, which would then release its address and the ISP could allocate it to somebody else. Now, with people having a smart TV, having a tablet lying around and being up and running all the time, and worst of all, people using IP telephony and insisting on being reachable all the time, more and more of these home routers are actually running around the clock and need an address. So even with the boring ISPs who are not growing, they need an increasing number of addresses all the time. The ISPs who have some more exciting technology underneath, like the ones using cable TV as an infrastructure, or even better, fiber to the home, fiber to the building, they are growing. So even the number of customers is growing and the address problem is really pressing for them. And that means they have to deploy IPv6 quickly. I've mentioned in the previous episode that probably by the end of next year, or by the end of this year, 2014, IPv6 should be widely available. And here's a few numbers to show that. Probably the best resource for numbers like this is Geoff Houston, who is chief scientist with APNIC. And in September at the RIPE meeting in Athens, in Greece, not Georgia, he showed various statistics and they pretty much all went exponentially up. Now, the absolute numbers depended on the region, and extrapolating exponential growths is notoriously imprecise. You can ask any mathematician or engineer about this, and as soon as you say exponential growth, you basically get two statements. Number one, it's pretty much impossible to predict for a reasonable amount of time, and the only thing you know is first nothing seems to happen at all, and then all of a sudden things go very, very, very fast. So the archetypical example for an exponential process is an explosion, despite the fact that really exponential processes are even faster than an explosion. So things are happening rather fast, but the numbers he had showed that in Germany we've had a growth of IPv6 deployment by a factor of about 12 within a year. And in mid-2013 we had about 3-point-something% people having access to IPv6. Another number I've heard, not from him, but from some source I consider reliable, but I'm not supposed to mention. By now we are at about 10%. And if you work the numbers there, by the end of this year in Germany we should have IPv6 generally available. Okay, now these curves, they grow exponentially, but eventually they flatten up again because they can't grow beyond 100%, but that's pretty much what it looks like right now. And from what I get from the various ISPs, they are frantically trying to get IPv6 up and running. So you might pretty well expect at least a significant number of people using IPv6 by the end of this year. And that means for software developers, hardware developers, that they can start to build products that use IPv6 as an infrastructure. We've been looking for a killer app for IPv6 for, I don't know, 10 years or so, and it didn't show up. Why not? Because nobody will build it if no potential customer has the necessary infrastructure to use it. Now that the infrastructure is there and people are getting familiar with IPv6, it's only a matter of time until IPv6 only apps, features, functionalities become available. The first two major ones we've already had are from Microsoft. With Windows 7 they introduced home groups which use IPv6 internally on your local network, so you don't even really notice, but they use it and it's IPv6 only. And the other one is called Direct Access, which has a few tricks to make it sort of work with IPv4 as well, but it's basically IPv6, and it is rather exciting to some businesses. I'm not going to go into more details there. Let's just say that it's imminent that people will build features, products, functionalities that rely on IPv6 to be available. So if you don't support IPv6 in your networks and on your internet connectivity, you're cut off from these. And by the time you realize we have a problem, our competitors are using these things, and you actually got IPv6 up and running, you'll simply lose time. And that's the smallest problem. The really nasty part is really what's going to happen to the internet IPv4, which is basically falling apart really. The ISPs are using some sort of last-ditch technologies to somehow connect people to some degree to the internet IPv4 side. And the first one is called CGN, Carrier Grade NAT. It's basically not done at the provider side. Needs lots of hardware, expensive hardware, and it doesn't work very well. The problem here is that for every connection from somewhere to somewhere else, you need memory in these devices. And if enough people open enough connections that these things run out of memory, connections fail. And that's what happens to a web browser trying to get a lot of small pictures at the same time, as in the web shop example I've mentioned. So at the busiest time, basically where you do most of the business with a web shop, an increasingly large number of people will see that your website appears broken because the pictures are missing or the website doesn't respond at all. And to make things worse, they'll click reload, 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 reload. So they open more and more connections and the entire situation escalates. And that means from their perspective, your web shop is broken. Now, if you have a competitor who also uses IPv6 or provides their web shop or whatever with IPv6, and they go there, they're not going to use the CGN gateway because they connect directly using IPv6. No problem with the pictures, everything is fine. And that means your web shop looks pretty bad. Same basically applies to email and such, except that if an email takes a couple seconds longer, well, people are used to that, so there's not that much of a problem there. So anyway, we do have a problem if we provide services only as IPv4. it'll be a gradual thing because only people who are stuck behind one of those CGN devices will be affected, but it's a problem. And to make things worse, CGN doesn't normally come by itself, but together with another technology called DS-Lite, dual stack Lite, which basically means that your home router doesn't talk to what they call an AFTR, address family translator, or translating router, which is a CGN gateway, but between your home router and the AFTR, you talk IPv4 over IPv6. And if that sounds kind of complicated, yes it is, and anything complicated is kind of troublesome, unreliable, especially when on one end of the line somebody is supposed to handle this thing who doesn't really understand what's going on there, which is the case with pretty much any home user. And that means things are getting even more expensive, and this DS-Lite technology will be even more unreliable than CGN alone. So we do have a bit of a problem there. And the worst thing that might happen, I'm not entirely sure about it, but from a business point of view I don't think there's an alternative really, is that because all these workarounds who are really a pain to operate, pain to use, the ISPs who are notorious for running on very low margins have probably no other option but to actually charge extra for IPv4. And that means if your customers are charged with paying extra for IPv4 and they don't even know, most of them probably don't even know what it is, but they don't see no reason to pay anything extra. If they don't pay, they don't get access to these CGN gateways and AFTRs, and that means they can't reach any IPv4 websites at all. And then you have a real problem. And will they pay? Should they pay? There are a couple interesting numbers there. About maybe a year ago, I've read a report from a university in South Africa, somewhere in the Orange Free State. I don't know which one it was right off my head. Maybe Pietermaritzburg. Anyway, they enabled IPv6 in their networks, which included the students' dormitories. And the moment they enabled it, more than 50% of the traffic was actually IPv6. Mostly YouTube and, well, YouTube and I guess it was YouTube and then probably YouTube. And that meant, as an ISP, if you only start today, you already have a problem. But it also means that people think that everything is working fine because most of the stuff works, which is YouTube, obviously. So if you expect people to pay extra for IPv4, which is a pain compared to IPv6, to reach your services, you have a problem. And now the obvious reaction to this is to say, okay, we'll wait until we actually see this happen. It's perfectly human approach, but the problem here is by the time you realize that you're losing money, because that's what you're going to notice, you'll have a number of problems. First of all, you have to figure out what exactly is the cause of you losing money, and then you have to somehow get IPv6 up and running, and quickly, because you're losing money. With every day it takes, you're losing more money. And that's usually getting real troublesome if you have properly staffed and properly working IT department, not the sort of near dead thing you see these days where everybody's just trying to squeeze money out of IT, then your people should have taken care of IPv6 beforehand, and you probably wouldn't have even noticed. If you've taken care about this 5 years ago, nobody would have noticed. It's just there and it works. People have put a lot of effort to make this possible, but it always depends on the people actually implementing it in the particular environment. So what happens here is that the problem will mostly affect companies, organizations where the IT department can't handle this by themselves because they are overwhelmed with work, they are understaffed, frustrated possibly, or outsourced anyway. And that's when things are getting really ugly, because there will be a rush towards it, and that brings in those imposters who say they're senior computer experts, and by that they mean that if you give them 5 tries to write computer, at least one time they almost manage to get it right, and they will show up again. And it's very difficult to tell these people from people who really know. And you're pretty desperate anyway, so every day counts, and you bring whoever you find in. Rather risky situation. And even you get some reasonable people, you have a problem. Because when every day counts, people take fairly desperate measures, and it's a fairly risky project in the sense of risk management in both IT and business. So you do have a problem there, and these crisis projects, you pay very much money for very little results, and for high risk that you don't get any results at all. I personally don't mind these projects. Basically getting anything you need and no discussions is nice. You can charge pretty much any rates you want, because all that counts is getting back into business. So fine with me, but that doesn't mean it's fine for you. So that's a problem there. And that is pretty much the situation we have with IPv6. The best thing that can happen is really you have people in your IT department who know about this, have taken care of this beforehand, and of course whenever we bought a network printer during the last 5 years, we made sure it supported IPv6, so we don't have to do anything about that, and who set up IPv6 while they're working on whatever part of your network anyway. Then you're through with this already, and there should be very little to do. But from what I've seen, I've been making a living out of these people, doing trainings to get them started, and then they sort things out themselves. But that's pretty much stopped, and by now we're starting to get these panic projects. They're just starting to pick up, but these things happen. And my guess is we'll see a situation similar to year 2000. Yeah, I'm sorry to mention that, but there have been people who refused to take care of the year 2000 problem until, November 99, and they paid dearly for that. We didn't blow up any nuclear power plants, but a lot of people spent a lot of money they could have saved if they had taken care of things a bit earlier. So I suggest talk to your IT people, see that this thing is getting done, and sort this out. I plan to do another episode on this, what it actually means to deploy IPv6, but that's probably gonna be a mini-series or so, because there's more to this than just technical stuff. IPv6 is largely a management problem these days, because you have to set the priorities, you have to provide the budget, and so on. And so I'll leave that for another probably 2, 3, maybe 4 episodes. This is just to make you aware of there's something going on. It will affect your business, most likely sometime this year, and please don't just ignore it, because if you do, you'll get unnecessarily hurt. So much about the background about this 3-minute IPv6 sales pitch. I hope you've got a bit more ideas of what's going on there and why it is important and why it is urgent. And if you want to discuss, come over to the forum at www.stepladder-it.com/BIVBlog/11 in this case. And otherwise, hopefully see you soon. Bye.